Sa TVKASYON.
Hello there! I am your teacher Angel and welcome to a whole new learning experience. I'm sure you had a great time studying your previous lessons. This is Module 1 of Quarter 1, Lessons 1 to 3 in Mathematics Grade 10. Have you ever wondered why such buildings with architectural designs can actually survive natural calamities such as earthquakes and prevailing winds? Well, for this episode, we will uncover the secrets behind its stability and durability. In this module, the most essential learning competency is solve and generate patterns. After working on the activities on this module, you are expected to solve and generate patterns, solve sequence using explicit form of sequence, and solve sequence using recursive form of sequence. Now, are you ready? Let's get started. Look at the pattern and think of the things that you notice about its characteristics. What have you noticed? First, all figures are quadrilaterals. Second, the three figures are repeating. Looking at how the figures are arranged, what do you think will be the next figure? Square! How did I know? By looking at how the figures are arranged. Now, if we continue the pattern, what is the 15th figure? Rhombus. How did I know? Rhombus is the third figure in the pattern. Positions in the order of the figures that are multiples of 3 will also be rhombi. Therefore, the 50th piece is rhombus. And now, you're ready to learn the lesson for today. So, what is a pattern? A pattern is an arrangement of things repeated in an orderly and recognizable fashion. If we try to look at the pattern, what will be the next figure? The answer is down arrow. How did I know? Because, as we can observe, the pattern has arrows which are moving in a clockwise direction, and the next item after the right arrow is a down arrow. How about this? What will be the next number? The answer is 11. Why 11? As you can see, the numbers are increasing with each term to more than the previous term. You got it right. In the previous example, we used numbers instead of figures. We call a succession of numbers in specific order as sequence. The numbers in a sequence that are separated by commas are the terms of the sequence. Using our previous example, 1 is the first term, 3 is the second term, 5 is the third term, and so on and so forth. The three dots indicate that the sequence goes beyond 11. We will also study forms of sequence, the explicit form of sequence and the recursive form of sequence. An explicit form of sequence is a sequence that can be expressed in a form in which a preceding term is not necessary to find the succeeding term. On page 12 of your module, write the explicit form of the sequence 5, 8, 11, 14. We can get any term in the sequence by adding the product of the common difference and n to a constant. Take note that the common difference is the value you obtain when you subtract the term from its succeeding term, while constant is any number that can be used to make the equation true. Therefore, the explicit formula of the sequence is a sub n equals 3n plus 2. Now, let's try writing the explicit formula for the sequence 2, 9, 16, and 23. Therefore, the explicit formula of the sequence is a sub n equals 7n minus 5. A recursive form of a sequence is a sequence if the first term and the recursive formula are given. A recursive formula is an expression used to determine the nth term of a sequence by using the term that precedes it. Look at this sequence. We can get any term of the sequence by adding the first term to the common difference. For the succeeding term, just add the preceding term to the common difference and so on and so forth. Therefore, the recursive formula of the sequence is a sub n equals a sub n minus 1 plus 4. Now, let's try writing the recursive formula for the sequence 17, 12, 7, and 2. Therefore, the recursive formula of the sequence is a sub n equals a sub n minus 1 minus 5. I know you understood the lesson. I'm sure you did. Learning patterns and sequences is fun, for you can see it in the things and in the environment around us. And now, let's do the activity entitled What's Next and What's My Formula? In the activity, you will have to identify the next 3 terms of the sequence, then write its explicit and recursive formula. I will give you 1 minute to answer. Number 1. Give me the next 3 terms, the explicit form, and the recursive form of the sequence 3, 9, 15, and 21. The next 3 terms are 27, 33, and 39. The complete sequence is 3, 9, 15, 21, 27, 33, and 39. The explicit form of the sequence is a sub n equals 6n minus 3, while the recursive form of the sequence is a sub n equals a sub n minus 1 plus 6. Number 2, give me the next 3 terms, the explicit form, and the recursive form of the sequence 25, 21, 17, and 13. The next three terms are 9, 5, and 1. The complete sequence is 25, 21, 17, 13, 9, 5, and 1. The explicit form of the sequence is A sub n equals negative 4n plus 29, while the recursive form of the sequence is A sub n equals A sub n minus 1 minus 4. Congratulations! You did a great job! Keep going! Before you proceed to the evaluation, let me leave you a reminder in getting the explicit and recursive formula of a sequence. For explicit formula, always remember to find the common difference of the sequence and find a constant number to be added to the common difference to get the next term. For recursive formula, always remember to find the number to be added or subtracted to get the next term of the sequence, or simply find the common difference. To practice your skill from the lesson presented, I want you to answer the following. You have 10 seconds to answer each item. Number 1. Is letter B, K. Why K? Because you skipped 2 letters to obtain the next letter. Very good. Number 2. Is letter C, 12. Why 12? Because, as you have noticed, the terms in the first, third, and fifth term is diminished by 1, while 10 is constantly appearing alternately. Fantastic! Number 3. Is C, 192. Why 192? Because the next number is obtained by multiplying the preceding number by 2. Excellent! Number 4. Is letter A. A sub n equals 10n plus 15. Why? Because the common difference is 10 and we simply add a constant 15 to it to obtain the next term of the sequence. Very good! Number 5. The answer is letter B. A sub n equals A sub n minus 1 minus 4. Why? Because we simply subtract 4 to the preceding term to get the next term. Fantastic! Wow! Congratulations! I am proud with the way you worked today. You have demonstrated your understanding on patterns and sequences very well. Give yourself a hand for a job well done. Some Sometimes in life, these small details, though little, can make a big difference. They're not just there for aesthetic purposes, but for many things too. And that ends our session for today. I hope you had a great time and learned a lot on this video lesson. See you on our next episode on arithmetic sequences. Thank you for watching. Keep safe and enjoy the rest of the day. Sulong edukalidad.